look around. There's no power grid. We're going to give every pole its own little power plants. Hi tech lovers, welcome back to Fast Cabling. So right here, this is where most surveillance projects die. So we just spent field days surveying this industrial park, a mountain highway, and railroad border. And our clients wanted eyes on every pole. But the quotes for trenching fiber and running grid power, it was a nightmare. The distances are too long, the terrain is too harsh, and the dust, well, you can see it. So today we are going to show you how we saved this project. We are throwing out the old playbook of centralized power and long copper runs. We're going decentralized. We're building a self-powered surveillance network using Passive Optical Network. And the best part is, the only thing running between this pole is a single string of glass. Now, to understand why we're doing this, let's look at the old way. In a traditional setup, you run a dedicated fiber line from the control room to every single camera. That means a lot of fiber. And then you have to pull copper wire or install giant transformers to power each pole. So in a spread out environment like this, that centralization is your enemy. If the power fails at the central point, everything fails, and if you have a break halfway down the line, you lose everything after the break. So it's fragile. And in this heat, with this storm, we needed something resilient. We needed something that distributes the risk and minimizes the cable in the ground. And here enters PON. Instead of running 20 individual fibers for 20 cameras, we run one single fiber, just one. It runs from the control center all the way along the highway. And here we have the core fiber. It can run up to 20 kilometers. And at the control center, we have the brain of the operation, the OLT, optical line terminal. This little box will manage every single camera out there, but it only has one cable leaving the building. Let's see. First, we need to connect the switch to our OLT for data. Then, use another short patch cord to connect our switch to the network video recorder so we can display video footage. Now it's done. Here comes our fiber optic cable. This is a 2-string single mode fiber pre-made, so we don't have to worry about the connector. It has 2 strings. Let's use string C. Plug it into the PON port connector, and let's plug it into the PON port. Simple. So in the control room, everything is done. Now, about halfway down the line, we do something that feels counterintuitive. Now, instead of bringing the fiber back to the office to split it, we are going to split it in the field. So we installed a passive optical splitter. Now, this is a magical device because it requires no power. It just takes the lights from that one fiber and divides it. Let's say 1 to 16 or 32 or 2 to 16, 32, up to you. But why do we do it in the field? Because it drastically reduces the amount of fiber we have to run, and since the splitter is passive, there are no electronics out in the field to fry in the sun. So let's connect it. Remember, we have the 2-string fiber optic cable. Now let's connect it to our splitter. This is a 2-in 16-out splitter. So let's connect it. And then we have our 2-string PON fiber optic cable. Again, let's plug it into our splitter. Just plug it all the way in until you hear the click sound. Now let's follow our fiber optic cable and lead to where the magic happens. This is our pole unit, our decentralized node. That single fiber from our splitter is going to connect into this compact box, the ONU, Optical Network Unit. Think of it as the receiver. It takes that light signal and turns it back into Ethernet for the camera. We have 2 string. Let's use string 1 here. Plug it into the PON port. Now this ONU can be smart too. You can add a PoE injector nearby it to power the cameras, or you can use an ONU that has built-in PoE, which means we can plug the cameras directly into the PoE ONU and powers the camera over the Ethernet cable. And there's no extra power injector needed at the pole. And now the coolest part is this ONU has a second Ethernet port. So suddenly this pole isn't just for security. We can plug in edge devices like air quality monitors or IoT nuts. We are getting dual purpose networking out of a single fiber string. But for now, we are going to connect an Ethernet cable to send data for our Bullet's camera. It's efficient, but we have a massive problem. The grid. Look around. There's no power grid. So in a centralized world, this is the final boss. You can't beat it, but in our decentralized world, we make each pole autonomous. We're going to give every pole its own little power plant. And here's the kit. We have a solar panel. It collects energy from the sun. We have the charge controller. It regulates the voltage to safely charge the battery without overcharging it. And we have the battery. It stores energy to power the cameras and the ONU at night or during cloudy weather. Now, in this dusty environment, when the light is low, the charge controller will extract every possible watts from the panel. But sizing this is a science. You don't just grab the biggest panel you can find. First, we do the load calculation. Our camera draws, let's say, 10 watts, and the ONU draws 5 watts. That's 15 watts total. And at night, we rely solely on the battery, so we have to size the battery to cover the night hours plus a buffer for cloudy days. But here's the rule. Don't oversize the solar panel to match the battery. You have to match the panel to the load and the sun hours. If we put a massive panel on a tiny battery, we'll cook the battery. So we size the battery for the night, and we size the panel to refill that battery during the day, plus run the camera simultaneously. It's a balancing act. So now let's connect them. First, we'll connect the solar panel to the charge controller. It's simple. There's negative and positive. Just plug them in until you hear the click sound. First, we are going to connect our output cable. It's in the back here. Let's plug it all the way in and twist it tightly. Then we are going to connect our battery to the charge controller. Again, there's positive and negative. Just plug and click. So it's done. And follow the output cable. We are going to connect it directly to the ONU. Here we go. We can see the power is on. The installation is clean, everything, the ONU, the charge controller, the battery, they're ready. We already plugged in the camera. It fires up, connects back to the OLT kilometers away. And now let's wait for the video feed to come up. Here we go. Now I'm waving a hand so you can see it's a live video feed. So what did we build? We built a surveillance network that laughs at long distances. We run one fiber, split it passively in the field, and gave each pole independence with solar. If a storm takes out one pole, the others keep running because they have their own power and their own fiber path. And maintenance is easy. You just fix one knot. You don't have to shut down the highway. So decentralized power and passive optical transport turn an impossible project into just another install. If you're facing a similar challenge, remote, harsh, spread out, stop trying to drag the grid with you. Bring the power to the pole. So we have the specific gear list in the description below if you need it. Thank you very much for joining us, and I'll see you in our next video.